The year is 2012, August 27th. Another day on Mars for me, Curiosity. I woke up to the cold, thin air. My batteries were charged, ready for a new Martian day. My job is to explore, to learn, to send data back to the humans on Earth. It's a big job, but someone's got to do it. My mission began long ago. Earth time, August 6th, 2012. I landed on Mars in a place called Gale Crater. My goal, to find out if Mars ever could have supported life. Every day I take pictures, drill into rocks, analyze the soil. It's slow, meticulous work, but every piece of data is a piece of the puzzle. A puzzle that could tell us if we are alone in the universe. Today is no different. SOL 717. Let's get to work. The first thing I do every morning is check my surroundings. As the sun rises over the Martian horizon, casting a soft glow over the landscape, I prepare for another day of exploration. The silence is profound, broken only by the hum of my instruments. My camera's whir to life, capturing the desolate beauty of Mars. Each image is a piece of a larger puzzle, a snapshot of a world that has fascinated humanity for centuries. The vastness of the terrain is both daunting and exhilarating. It's a harsh world, this red planet. Dusty plains stretch out before me, dotted with craters and mountains. The landscape tells a story of a planet shaped by ancient forces, of violent impacts and shifting tectonics. The sky is a pale pink, the air thin and cold. It's a stark contrast to the blue skies of Earth, a reminder of how different this world is. Yet there's a certain allure to the Martian sky, a beauty that is uniquely its own. But there's a stark beauty here too, a sense of ancient history, of secrets waiting to be uncovered. Every rock, every grain of dust holds a piece of the past, a clue to the mysteries of Mars. I can see the layers of rock in the distance, a record of Martian time. Each layer tells a story if you know how to read it. These formations are like pages in a book, waiting to be deciphered. Today, my cameras are focused on a nearby rock formation. It's a fascinating structure, shaped by eons of wind and erosion. The details are intricate, each crevice and ridge a testament to the forces that have sculpted it. It's a jumble of rocks and dust, shaped by wind and time. The patterns are mesmerizing, a chaotic yet beautiful arrangement that speaks of the planet's dynamic history. But something about it catches my eye. A glint of light, a strange shape. It's moments like these that make the journey worthwhile, the thrill of discovering something new and unexpected. I zoom in for a closer look. The details come into sharp focus, revealing textures and patterns that are invisible to the naked eye. Each discovery, no matter how small, adds to our understanding of this enigmatic world. This is why I'm here, to explore the unknown, to see what others haven't seen, to push the boundaries of human knowledge and to uncover the secrets that Mars holds, to follow the clues, wherever they may lead. Each day brings new challenges and new discoveries, and with each step, we come closer to unraveling the mysteries of the red planet. My cameras can only tell me so much. They capture the vast, desolate beauty of Mars, the endless stretches of red terrain, and the distant horizons. But to truly understand this planet, I need to go beyond what I can see. To really understand Mars, I need to get my robotic hands dirty. My mission is to uncover the secrets buried beneath the surface, to dig deeper into the Martian soil and reveal its hidden stories. Today, that means taking a closer look at the Martian soil. Each grain of dust holds a piece of the planet's history, a fragment of its geological past. I use my robotic arm to scoop up a sample of the reddish-brown dust. This soil has been shaped by eons of cosmic events. From meteor impacts to volcanic eruptions. It's fine and powdery like talcum powder. But don't let its appearance fool you. This soil is a treasure trove of information, but this is no ordinary dirt. This is Martian regolith, the product of billions of years of cosmic bombardment and geological processes. Each particle tells a story of the planet's tumultuous past. This is Martian regolith, the product of billions of years of cosmic bombardment and geological processes. The soil here is a witness to the planet's history, from its fiery beginnings to its current state. My onboard instruments analyze the sample. They are designed to detect even the smallest traces of minerals and chemicals, providing a detailed picture of the soil's composition. They identify the minerals present, the chemical composition, the presence of organic molecules. This data is crucial for understanding the planet's potential to support life, both in the past and possibly in the future. Each data point is like a word in a sentence, slowly revealing the story of Mars. The more data we collect, the clearer the picture becomes. The soil here is rich in iron oxide, which gives Mars its distinctive red hue. This iron oxide is a clue to the planet's past interactions with water and atmosphere, but there are also traces of other minerals, sulfur, chlorine, even hints of water molecules locked within the crystalline structure. These elements suggest that Mars once had a more dynamic environment. These are clues, hints of a more active past. By studying them, we can piece together the history of Mars, understanding how it evolved and what it might have been like billions of years ago. Each discovery brings us one step closer to unraveling the mysteries of the red planet. Remember that strange rock formation I mentioned earlier? The one that caught my eye? Well, I've maneuvered myself closer, and I'm ready for a closer look. It's a hunk of rock, about the size of a basketball. It's dark gray, flecked with white. What makes it stand out is its shape. It's almost perfectly round like a giant marble. As I approach, the details become even more fascinating. The surface of the rock is smooth, almost polished, which is quite unusual for Martian rocks. Most rocks here are jagged and rough, shaped by the harsh winds and dust storms that sweep across the planet. I use my laser to zap the rock, vaporizing a tiny portion of its surface. The light from the laser excites the atoms in the rock, causing them to emit light of specific wavelengths. My spectrometer analyzes this light, revealing the rock's composition. The results are intriguing. This rock is unlike anything I've encountered before. It's high in silica, a mineral commonly found in volcanic rock on Earth. But there are also traces of other elements, lithium, boron, zinc, in unusual ratios. These elements suggest that the rock may have formed under conditions that are different from those typically found on Mars. This is a mystery, a puzzle to be solved. Could this rock be evidence of past volcanic activity, or could it be something even more intriguing? The presence of high silica content and the unusual shape of the rock make me wonder about the geological history of this area. Was there once volcanic activity here that created such unique formations? Or did some other process shape this rock into its current form? The roundness of the rock is particularly puzzling. On Earth, such shapes are often formed by water erosion, but Mars is a dry, barren planet. Could there have been water here in the distant past that shaped this rock? Or is there another explanation? Only further analysis will tell. I'll continue to study this rock and the surrounding area, looking for more clues about Mars's geological history. Each discovery brings us one step closer to understanding the red planet and its secrets. The more we learn, the more questions arise. This rock is just one piece of the puzzle, but it's an important one. It challenges our assumptions and pushes us to think differently about Mars and its past. As I continue my journey across the Martian landscape, I'll keep my sensors tuned for more anomalies like this. Each new discovery adds to our understanding and brings us closer to answering the big questions about Mars. What other secrets does Mars hold? What other mysteries lie hidden beneath its surface? Only time and exploration will reveal the answers. For now, this rock remains a tantalizing clue, a hint of the complex and fascinating history of Mars. I'll keep investigating, and who knows what I'll find next. The journey of discovery continues, and with each new finding we get a little closer to unraveling the mysteries of the red planet. This is what exploration is all about, the thrill of the unknown, the excitement of discovery, and the quest for knowledge. Could this rock be evidence of past volcanic activity, or could it be something even more intriguing? Only further analysis will tell. The journey of discovery continues, and with each new finding, we get a little closer to unraveling the mysteries of the red planet. Only further analysis will tell. Section 5, Red Planet Road Trip Navigating Hazards. Exploring Mars isn't just about science, it's also about navigating a harsh and unforgiving terrain. My wheels churn across the rocky surface, leaving tracks in the ancient dust. Every meter I travel is a victory. The Martian landscape is littered with obstacles, sharp rocks, deep craters, treacherous slopes of loose sand. One wrong move could spell disaster. My human controllers back on Earth plan my route carefully, using images from my cameras to identify potential hazards. But even with their guidance, I need to be careful. I rely on my hazard avoidance cameras to spot obstacles in my path. My onboard computer processes this information, making tiny adjustments to my course to keep me safe. Section 6. Power up solar energy on Mars. Even robots need to recharge. My power comes from the sun, captured by my solar panels and stored in my batteries. But the sun's energy is weaker on Mars, and dust storms can block out the light. Every day I need to make the most of the available sunlight. My solar panels track the sun across the sky, maximizing their exposure. I carefully conserve my energy, powering down non-essential systems when not in use. Today, the sun is shining brightly, bathing the Martian landscape in a warm glow. My solar panels soak up the energy, replenishing my batteries. I feel a surge of power, ready to continue my exploration. Section 7. Data to Earth, the long journey home. I gather a lot of data images, sensor readings, analysis results, but this information is useless unless I can send it back to Earth. Several times a day I establish contact with Earth, using my high-gain antenna to beam my data across the vast gulf of space. The signal is weak, and it takes time to transmit large amounts of data. But it's worth it. Every bit of information I send back helps scientists on Earth to understand Mars better. It's like sending postcards from another planet, sharing my discoveries with the world. Section 8. Unlocking Ancient Secrets, What We've Learned. I've been exploring Mars for over 700 sols now, and I've learned a lot. I've discovered evidence of past water, suggesting that Mars was once a much warmer and wetter place than it is today. I've found organic molecules, the building blocks of life, and I've analyzed the Martian atmosphere, learning about its composition and history. These discoveries are important because they help us to understand if life could have ever existed on Mars, and they provide valuable information for future human missions to the Red Planet. Section 9. Mars Beckons, the Future of Exploration. My mission is just the beginning. One day, humans will walk on Mars, following in my tire tracks. They will build habitats, conduct research, and explore this alien world firsthand. The data I'm gathering will help them to prepare for this journey. It will help them to choose landing sites, design life support systems, and understand the challenges they will face. Mars is a harsh and unforgiving world, but it is also a place of wonder and possibility. And I, for one, am excited to see what the future holds for human exploration of the Red Planet.